Today we are covering 4 problems in the risk analysis. So one for discrete random variable, and one for 2 random variables, and one for continuous random variable, and one example for decision tree. So the first problem is about the discrete random variable. So let's spend several minutes to read through this problem, and if you have time, please work that out yourself first, and then we can go through it together. Okay, so let's get started. For the problem A in this one, we are asked to calculate the expected present worth variance of the present worth and the standard deviation of present worth. So the first thing first, so let's calculate the present worth of getting this equipment. So we have 2 parts. The first part is the capital cost. So, and we use negative sign for the cost. So it's 418,000 plus the annual savings, and we use positive number. So when we want to get the present worth, and we use the P given A factor. So that's 148,000 times P given A for the rate 15%, and for that's let's just put n years here. So because we have a useful life that has a probability distribution, so we are uncertain about its useful life for some number of years that ranges from 3 to 8, given in this table on the left. So we want to calculate this present worth for each year, and then we can take an expectation of that. So that means we add up the probability times the corresponding year's present worth, and we add them together. That's the expected present worth. So let me just take a shortcut where I put the number of years in this parentheses. So actually you can just plug in these numbers and check yourself. I would just give out the solution right away. So for the third year, for year useful life of 3 years, so that's going to be minus A0086 present worth for 4 years. That's going to be 4540, and so on. Let me drop down these numbers into 8 years. 5 years, 78126. 6 years, 142106, and 7, that's 1937739, and 8, that's 246120. Then we are just use this formula to calculate the expected value. So that's so since we have a discrete random variable, so we use a summation sign for all the scenario of x, and we add up the px times x. So now here this x are from like present worth of number of years, 3 years, the present worth to 8 years. So let's use the table here, and we just use this probability times corresponding present worth, and we will get our expected value. So for year 3, that's A00A6 times 0.1 plus 4 years, 4540 times 0.1, and 5 years times 0.2, 6 years times 0.3, 7 years, 0.2, and 8 years. That's 2, 4, 6, 1, 2, 0 times 0.1. And then we will get 1148. So this is the expected value of the present worth. So given the expected value calculated, that's easier to calculate the variance. So now let's calculate the variance of the present worth. And that's actually, we are going to use this formula still for all the cases, and then we add up the x minus expected x and take the square of that and times px. Okay, so that's just very straightforward. We're just plugging these numbers as above, but instead we are going to use this variance formulation. So for the 3 years, now we have minus A 0, 0, A6 minus the expectation we just calculated. So I just simplify this number, use my notation E of x. So I'll just put E of x here, square times for years, 3 years, and for 4 years, that's 4, 5, 4, 0 minus EX squared times 0.1, and then 7A126 minus EX squared times 0.2, 1 over 6, that's for 4 years, minus EX times 0.3, and this 7 years, 197, 739 minus EX squared times 0.2, the last guy, 246,120 minus EX squared times 0.1. Okay, then we're just getting close to the solution, which will be a very large number, a 6 or 6.8 times 10 to the power of 6. So that's the variance. Then the standard deviation of the present worth will be very straightforward, so which is just the square root of the variance of the present worth, just calculated. A 6 or 6.78 times power of 6. Then we will have some number close to this guy, 92773. And we are done for problem A. Yeah, so for doing problem like this, just get familiar with the expectation and variance formulation, and you can solve these problems quite easily, and you may want to take a note when you take an exam. So next, let's do problem B from first problem. So it's asking what's the probability that the present worth is gonna be less than 0. So let me write out the notation. So P, the present worth less than 0. So actually, we can see from our calculation. So when we have the present worth less than 0, that's when the n equals 3 years. So that's actually corresponding to this table in the first row. So 3 years, we have the probability P3 equals 0.1. So since we have the present worth of 3 years, that's a negative number, A6. A00, A6. So that's actually corresponding to the first row, and we put 0.1 there. Very straightforward. And for the recommendation on purchasing this equipment, so first we have the expectation of the present worth. That's the number is 114,862, and actually that's a positive number even with considering of the variance or standard deviation. Yeah, standard deviation, since that's in the same unit, which is 92773. We even this expectation is even larger than the one standard deviation. So that's fairly favorable. And also, what's more important is the probability of getting a negative. The probability of getting a negative present worth is pretty small. That's 0.1. So in considering all of these factors, we would recommend purchasing this. And we are done. Now let's look at the second problem, and as always, please spend a few minutes to go through this problem yourself, and then let's go through it together. Okay, I think we are good. Then, so for solving this problem, the spirit is to get familiar with the different variations of the form of the random variable when calculating the expectation of variance. Specifically, let me write out some of general rules. So when we calculate a expectation for a random variable x, say, then if we have another like constant cx, where c is a constant, and when we calculate this expectation, we can just take out the c out of the expectation, and we will have c times the ex. And remember the sign is included in the c. And for the variance, that's a similar story, but remember, when you take out the c from the variance, you should take square of that, and it will have the variance of x. And the derivation of this guy is very straightforward. I think the derivation in the textbook page 507, equation 1210 is very clear, and you can just check that out and get a more clear understanding on that. But for convenience, I can also show some of the steps instead. So why we are getting this square sign? Because let's start with the original formulation. So the variance would just be the expectation of like a Cx minus expectation of Cx. And we need to take square that and take the expectation of that. And then we will have expectation, so we can just expand the equation inside. So we have Cx squared minus 2 times C x expectation of Cx plus expectation of Cx squared then we can further expand that. So as we already know, the C can just take out of the E, so you have minus 2C squared x Ex plus, and we take that out as well, C squared Ex squared. And we notice here for each component we have the C squared. So as we know, for the rule in the expectation, we can just take this constant out of the E. So we have x squared minus 2x Ex plus Ex squared. This is exactly the variance, but let me just write out the expression. So that's x minus Ex squared. The expectation of that's just the definition of the variance of x. So that's why we are getting this expression. So that will be, so what will be the C for example, in this problem? So the C will be corresponding to these like numbers before the x's in this table, and the other guy could be the factors, like you transfer your time value of the cash flow, like P given A, P given F. Once you plug in these factors, they all can be considered as the C here. So now let's go through this problem in detail as an example to show the spirit of using those above rules. And for the first one, we are asked to calculate the mean and the variance of the present worth of all these cash flows. So to do this, we just calculate year by year. So we have that K just note of the year, denote the year, and then so we first calculate the expectation of the xk, so that's the 3-point estimates, and then we further calculate the expectation of the cash flow fk, and then we take the present worth of that Okay, so now let's look at the first year, year 0. So the expectation in this example is very straightforward, listed by this problem. So we are gonna just use that formulation. So for the first year, that's just 1 over 6, and we add up all these estimates from L to H. So H is minus 45,000 plus 4 times the middle one, that's minus 41,000, and plus the low, which is minus 38,000, and we will have minus 41,167. So now we are just calculating the expectation of xk, and then for the next step, so expectation of, so that's expectation of x0, and now then let us calculate the expectation of f0. So f0 we have in this table, that's just x0. So we just keep the number from the expectation of x0 there and copy it down. And the next step is to calculate the present worth of the EF0. So since it's at year 0, we just copy it down. We don't need to change it to, it's already in the present word form, so we don't need any factors here. So that's very straightforward for the year 0 on calculating the expectation. And then for the variance, that's the same thing. So we calculate the variance of x0 first, which is just given in this problem. We use the high minus low, minus 45,000. Since low is a negative number, we just use plus here, 38,000 divided by 6, and take square of that, and we will have 1,361,111. That's the variance. Since the f is just the x0, so that's the same number here, and the present worth of the variance of f0 is still at a year 0. We just copy down that number as well. So that's straightforward. So now let's look at a more exciting form. That's in year 1. So 1k equals 1. So we have all the other things as the same. So calculate the expectation x1, take the expression 1 over 6 high plus 4 since the middle is the negative number, we just have the negative sign here, and then that's 4 times the middle number, 2,200, and minus 1,900. That's a low, and we will have minus 2208. But now the cash flow F1 is actually 2x1. So that's the form we have seen in the previous illustration on this constant times the random variable x, and take an expectation of that, which we can just take out the c out of the expectation and just times the expectation of x. So we just use 2 times 2 minus 2208, and we'll get minus 4416. And then we can further take the present worth of this guy. Since it's year 1, we just apply the p given f factor, hurdle rate 15%, and 1 year, and we will have minus 3840. Okay, then for the variance x1, that's the same story. So you just take the 1/6 times high minus low. This is high, and plus the 1900, and that 6 is inside, so that number divided by 6, and square of that, we will have 11736. Okay, so the next one will be a little bit tricky. To calculate the present worth of the variance, we really need to put the c in this table, which is 2, and the factor together as a constant. So the present worth of the variance f1 will just be we have the c and the p given f factor 15% and k x. So we're gonna just take these guys out, and the k here is 1, so that's c1 p given f factor 15% 1, and take the square of that and times the variance of x. So the c1 here is just 2, so that's just 2 times p given f 15% 1 year squared times the variance of x. And if you like to use the mathematical expression of the p given f factor, you will notice that it's just 1 divided by 1 plus I. So this n is number of years, and when you take a square of this factor, so when you take square of that, that's just going to be 1 over 1 plus I to the power of 2n, which means this expression is equivalent to 4 times p given f hurdle rate 2 times the variance of x. This is just for simpler notation. Definitely you don't have to do this. You can just use this original expression to play safe. But anyway, we are gonna get the same number through this calculation, which will be 35499. So to ease the confusion here, why we are doing variance, we put in this factor inside this variance expression. We're not doing that in the expectation. So you're right, you can actually put that the p given net factor in the expression as well, but there will be no difference of doing that, since c is a constant there and is in this f equals c times x form, and the factor is actually not a variable, it's a constant. Once you plug in the k, that will just be a constant. So this constant 1 and constant 2, and you can just think them as 1 and bring that out. That would be the same thing to calculate the present worth of the EX or EF. Okay, so from k equals year 2 to year 5, we all see these are just different numbers, but they're just following the same spirit and idea of solving year 1. So I'm not gonna just write out all steps, but instead I'm gonna give out the solutions for the expectation of the cash flow and the variance of cash flow in present worth for year 2 to year 5. So I just wrote out this table of the expectation of the present worth of the cash flow at year k. And you can check out the solutions, but with the actually exactly the same setup we just did for calculating year 0 and year 1. That's very straightforward. So now let me write out the variance from year 0 to year k. Okay, now we got another table of the variance. So the variance of the present worth of cash flow at year k. And they all have this relationship. And now we are ready to calculate the the expectation of the total present worth and the variance of the total present worth. So that will be just summation. Take the summation of these guys for the expectation, and summations of these guys as the variance. So the expectation will be from year 0, k equals year 0 to year 5, and we sum up all that we have. That's F0, that's Fk. And we have this 1, 3, 5, 4. The variance of the present worth will just be the summation of all the variance of present worth at year k, which would be 1, 6, 3, 9, 2, 4, 0. And we are done for the first problem. Then let's look at the second one. So it's asking that what's the probability that the present worth will be greater than or equal to 0. So let's first write down the notation. when the present worth greater than 0. And to get this probability, so we first need to assume some probability distribution on this random variable present worth. And we are gonna assume, since we only learn about the normal distribution, so we can still keep using this probability distribution. So we're gonna assume that the present worth of the net cash flow follows a normal distribution. With the mean, we just calculated, equals that present worth, the expectation of the present worth, which is 1354, and the variance. So usually we write the standard deviation, but we take the square of that, and that will be the variance. And is 1639240. And then since we are gonna use this appendix to get our estimation of this probability, so we first need to convert this normal distribution, and just let it be the normal distribution of the mean and variance we have, then converted that to a normal with mean 0 and variance 1, as we have seen in this on the left hand side. So the probability distribution, this normal distribution we have is at the mean is 0, and then the variance is 1. So we want to convert that to really get the probability. So that's just the area under the curve, under this curve before the value C. So to do this conversion, we have to know where is the number we want to be compared with. So in this problem, we're comparing this 0. So we're gonna put 0 here, minus the mean, and divided by the standard deviation. That's the statistic C, and that equals minus 1.06. And this C calculated here is corresponding to the normal distribution with the mean 0 and variance 1, as in this plot. So let me restate the meaning of this one. So the mean of the current distribution we have is at 1354, and the variance is this guy. But we want to find the Z that's corresponding to a standard normal distribution with mean 0 and variance 1, so that we can use this table. So to find the relative position of the 0 corresponding to this mean we have for now, and convert that to this the standard normal distribution. So we need to use this number, the number like 0 here. We want to find its position, and minus the mean of the current current normal distribution, and divided by the current standard deviation, and then we will have this relative position of 0. That's the z number here. Okay, so now we can rewrite what we have as the probability that present worth greater than 0 will be the probability that z is larger than or equal to 1.6. But still, we want to use this table so that we want to find something like p. We can only find this p z less than or equal to some number. Here is 1.06 from the table. So we did need to do a little bit of conversion, since this probability is just the area under the curve, and the total area under this normal distribution of all the probability distribution will always be 1. So then we will have that this guy equals the z less than or equal to 1.06. And to find this value in this table, first we can locate the integer and the first decimal point of z value. So minus 1, that's down below here. And check the second decimal point, that's 0.06. And we can find this number, that's 1446. So we have 1 minus 0.1446, which equals 0.8554. Okay, so let's get back to the problem. Actually, we just found the probability of that present worth is larger than or equal to 0, which is this one. And we are done. Now for this third problem, we're going to use the probability language to compare alternative B and alternative A. So to do that, we need first calculate the expectation and the variance. And now let's get started. So for the first problem, we are going to calculate the mean and the standard deviation of the incremental present worth delta B minus A. And that's actually what we want to use for the second problem. So let's do the first problem. So let me list out the key components column by column, and I will calculate row by row. So you have the column like end of year K, and then our expectation of the delta B minus A and here is the mean of the delta B minus A. It's just, and then the variance of B minus A. So that's actually very straightforward. So for year 0, we just use the B minus A. It's minus 4,000, and the variance of that, since so this actually, these concepts is related to when we have a form of two random variables like x plus y. So x, y are random variables. Then we have expectation of E plus Y. That's just, we can just take out that every component out. So we have the summation of the expectation. And for the variance, that's just the summation of these variance. So why this is a plus sign? So remember, you can understand that as b plus like -1 times a, and -1 is a constant. So when we take out this constant out, so we're gonna do the square of that, and that's just 1. So we will have a just plus sign there. Okay, so to get this variance, since we have 0 as a standard deviation for alternative A, so for B we're gonna just take the square of the standard deviation of B is 500, so we get 500 for the first year. We're gonna just do the subtraction from B, subtract A from B, so 4,500 minus 4,000, which is 500, and the variance, so it's basically it's a summation of the square of the standard deviation of the both alternatives. So that's 300 square, and that's 450,000. Okay, that's for year 1. And for year 2 to year 4, we are just following this exactly the same pattern. So let me just write down, skip the intermediate step and just write down the solution. So the expectation of the increment B minus A, that's minus 1,500, and the variance would be just 600 squared plus 300 squared, exactly the same thing. So that's 450,000, and for third year, that's 4,500 minus 4,000, that's 500, and 800 squared plus 300 squared, that's going to be 730,000. And for the fourth year, 4,500 minus 6,000 minus 1,500, and 300 squared plus 800 squared, that's going to be the same thing. This guy. And we have all the ingredients ready. The next step is we need to convert the expectation as variance to the present worth. So let's do the expectation, the mean first. Then it's just convert those year by year. First year, it's fine. Yeah, so just a reminder for doing this, we just use this concept. So it's constant times x. So x here, you can just take x as b minus a. B is a random variable, a is a random variable, so b minus a is still a random variable, and we can take that, you can simplify that notation as 1, so as x. So we can have this form still applied, and then for the first year, 500 p given f, 15%, 1 year. minus 1500 p given f 15% at 2 years. Since I'm just going to simplify that and take the same thing together, since we have the 4th year is minus 1500 as well, so I will just plus another factor here. There's a distribution rule, so p given f, hurdle rate, and 4 years. And for 500, we can do the same. So we have 3rd year is exactly the same amount as the future value, but we just change the years in the factor. And this so that's 3 years. And then we will have this as minus 5,228. Okay, that's quite straightforward. And for the variance, the present worst, b minus a or x, can still do the same, but instead, remember the c here was taken out, that we should place a square on the c. So for the 1st year, we don't have any conversion, so that's just copying down the variance. And for starting from the 2nd year, we're gonna have the factor part. So for the 1st year, 450,000 times p given f, 15%. And we have to place a square there. And for the 2nd year, still the same number, p given f, hurdle rate, and 2 years, and take square of that. And for the 3rd and 4th, I'm gonna just simplify a bit in this notation. That's actually p given f, 15%, 3rd year square, and p given f, 15% of 4 years square. Yeah, just another reminder. So that's p given f factor is actually written in this form, 1 plus 15, so the number of years. So once we take square of that, it's actually, that's just double the n. So we have 2n, which is exactly the p given f factor, 15%, and 2 times n. So instead of writing the square sign there for the p given f factor, so this is just for the p given f factor. For other factors, you have to check the derivation. It may not apply. So that's gonna be, that's equivalent, actually equivalent. And this guy is equivalent to 4 years, and this equivalent to 6, and equivalent to 8. But anyway, you should get the same answer, but just play safe to use the method you feel most comfortable and most confident. Then this guy we will have 1401 791. And we are done for our first problem. Oh, sorry, just another additional small step to get a standard deviation. Almost forgot. So okay, just take the square root of the variance, and we will get this guy for the standard deviation. Now we are done for the first problem, and for the second one, becomes more straightforward when we have this. So we want to have this probabilistic language of describing some alternative is better than the other. So we can set here we first set a baseline as the negative part. So you actually have this form as what we have seen in the first problem. So x equals b minus a. We can think that as the present worth of b and present worth of a. So both are random variables. And x is a random variable as well. And a is if we put the b at the first guy, like b minus a, that means we want to calculate the probability that b is better than a. And actually, we are just calculating the p x greater than or equal to 0. So b better than a, that just means b minus a is greater or equal to 0, since we're calculating the net cash flow. So when we have the positive cash flow of b and take expectation of that, we still get a positive number, and then we will say that b is better than a. So it's exactly equivalent to say that x is greater or equal to 0, and we need to calculate this probability. Okay, so to do that, we are going to use our very familiar friend. We first need to assume that this present worth is still following the normal distribution with the mean. We just calculated. That's minus 5228, and the variance is 1183. Oh, that's standard deviation, so it's actually 1401,791. And to find the relative position of the value 0 in this standard normal distribution with the mean 0 and variance 1, so we need to calculate the z statistic. It's called z statistic. So 0 minus the mean and divided by the standard deviation, which is about 4.41. And to use the table we have, we might need to use this transformation again. So y minus px less than or equal to 0. And that just pz less than or equal to 4.41. But unfortunately, this one not included in the table. So you can use computer or use computer to calculate that. You can search online, use any normal distribution calculator, and you can get this one. That's a very close number to 1.9999. So we only get 0.40 and 1. It's a very small number. We can almost say it's kind of unlikely that the probability of x will be greater or equal to 0. So just write out it again. So we're gonna conclude for this this problem. So alternative B is almost unlikely better than A. Or we just say is at this percentage, like it's better to say B is better than A. With the probability. .0001%, which is really small, but you can almost say that's unlikely to happen. And then we are done for this problem. Now we are coming to this decision tree type of risk analysis problem, and it's quite related to the previous concept we have seen. So actually we can treat as the branches of the decision tree as the like different scenario that will happen. So like as a discrete random variable. So now let's just take this example to explain. So basically for this decision, we have two decisions. So do nothing or introduce the new product. So let's calculate, and then we want to use the present worth to compare the both options. So we call the do nothing strategy as A and introduce as B. So when we calculate the present worth of A, as we see, if we do nothing, we don't have to invest anything and we don't have any profit in the following 8 years. So the present worth for A will be just 0. And that's very straightforward. Now let's look at present worth of B. So introduce the new product. So first capital investment at end of year 2. So we need to convert that to the present worth. So 1 million, negative 1 million times the P given F factor, 8% hurdle rate, and the interest rate, and then 2 years. And now we are gonna have this 2 branches. So we are taking the expectation of the different branches, so which is just the summation like we have calculating for the expectation of x. So just summation of all the scenarios. Okay, then calculate the xk times pxk. So the xk means that k equals 1, k equals 2. So for the first scenario, so k is the label of this scenario. So we have scenario 1 and scenario 2, and we have scenario 1 with a probability of 0.6, and for scenario 2 we have a probability of 0.4, and then we just add those up like it has been said in its expression. So first write down the probability for the first scenario, and the xk part would be the present worth of this cash flow. So 20 is 200,000 per year profit, and for 6 years, and this starts at year 3. So we first need to calculate the relative present worth. So for the 200,000, take the present worth. So p given a factor 8%, and that's for 6 years. And notice, since that annuity happens at the end of year 3, which means the present we calculated is at end of year 2. But then to get the present worth, we need to further take that back. So it's actually the future. So we need to use the p given net factor 8% and 2 years. So that's at year 0. Then let me get the second scenario with the probability 0.4, and now it's 280,000, and that's the same thing, unless it's just getting a different a. So we're still using the p given a factor to transfer to the relative present worth. So 8%, 6 years, which is also at the end of year 2. And we further convert that back to the present worth using the p given f factor, and 8%, 2 years. Okay, then we will have all these above numbers calculated. That's 62165. So that's actually exactly significantly better than A, which is 0. So we will conclude introducing a new product is better. And we are done. Thank you for watching. Please let me know if you have any questions. You can shoot me an email. And good luck to your exams.